Yes, student, here we are dealing the next content. This is the Freundlichs adsorption isotherm. Actually, the Freundlich studied the effect of pressure on the rate of adsorption. Okay, at constant temperature. Therefore, it is called isotherm. Therm means heat means temperature. So, at constant temperature. Student, by the simple general observation, you know that when the air speed is more, that is the air pressure is more, then we observe that more amount of dust, soil, etc. stick over the surface of adsorbent like almirah, glass, tabletop, etc. What it shows? It shows that if the pressure of adsorbent increases, the rate of adsorption also increases. But now think, if there will be more and more and more pressure, then what? Gradually the adsorption will take place. That means what? On your tabletop you will find that amount of dust, or your wall you will find that amount of dust or air or any of the thing. Actually, no. Okay. For some time, the rate of adsorption will be proportional to the pressure. But what? After some time, that is after some more intermediate pressure, now the rate of adsorption will little lesser. There will be increase but will be little lesser. And if the pressure will be very high, then what? Now the equilibrium will attain between adsorption and desorption. This is called equilibrium pressure. In this equilibrium pressure, there will be no adsorption. So that was studied by the Freundlich at constant temperature, and the effect of pressure at constant temperature on the rate of adsorption. He plotted the graph between amount of the adsorbed amount of the gas adsorbed per gram of the adsorbent, which is denoted by X by M. This is what? X means what? Amount of adsorbate, and M is what? In 1 gram of adsorbate surface, and the equilibrium pressure of the adsorbate, that is pressure of adsorbate, at constant temperature. This graph is known as Freundlich adsorption isotherm. We can draw like that here. Let we are plotting the graph between X by M. What is this? Amount of gas adsorbed on per gram. Okay, adsorbate surface. This is X by M, and this is what? Pressure. This is what? Pressure. So when he plotted the graph, he observed that initially at low pressure at constant temperature, okay, we got this straight line. What it shows? It shows that at constant temperature, if the pressure is increases initially, the rate of adsorption also increases and is directly proportional to P to power what? 1. Okay, that is the X by M depends on pressure, but you can call it, suppose this is O and this is what? A. When more pressure is increases, now the rate of adsorption increases but increase is little less. It is denoted by A and B. And when more and more pressure of adsorbate is increases, now there is what? Point C. That is what? A to B, the rate of adsorption, that is X by M, is directly proportional to P, but not with power 1, but it is power of 1 by N. Here n is greater than 1. N is greater than 1. But B2C, now the rate of adsorption x by m is directly proportional to P to power 0. That is what? Even if more pressure is increases, there is no adsorption. Getting? So here three type of point is obtained. This is called saturated pressure. PS, that is what? Saturated pressure or equilibrium pressure. Getting? This is at what? Constant temperature. Getting? Student, we can also observe this. If we increase the temperature, suppose it obtained at 373 Kelvin temperature, that is constant temperature. Now suppose we try to draw the graph at different temperature, x by m versus what? P. So let it is obtained like that. Here what? O, this is A, this is A to B, and this is what? C. And let the temperature is 373 Kelvin. You know that the rate of adsorption is inversely proportional to the temperature. That is what? If there is low temperature, there will be more adsorption. That means if we decrease the temperature, we will get this graph. And if we will increase the temperature, we will get this graph. So here you can see this is the decreased temperature, 353 Kelvin temperature, and this is increase in temperature, 393 Kelvin temperature. Are you getting? Now, now three observations are there. Three observations. Okay. Observation number A. This is what? At low pressure. At low pressure. Okay. You can call it what? OA. X by m is directly proportional to P to power 1, or you can call it x by m is equal to K into P to power 1. This is equation number 1. Getting? At intermediate pressure, you can call it what? A to B. Now x by m is directly proportional to P to power 1 by n, or you can write it x by m is equal to K into power P 1 by n. This is number 2. And at high pressure, that is what? Saturation pressure. Okay, high pressure, that is called A to C. You can call it x by m is directly proportional to P to power 0, or you can write x by m is equal to K into P to power 0. Okay. To show the validity, we can use intermediate pressure. Intermediate what? Pressure. Okay. That is what? A, B graph. Okay. Here what? X by m is equal to K into P to power 1 by n. Getting? Taking log, we will get what? Taking log, we will get log x by m is equal to log K, okay, plus 1 by n log P. Okay. So if we plot the graph between log x by m and log P, okay, it is observed that it gives the straight line where the slope, that slope is given by 1 by n. and the intercept is given by log what? K. Okay, it shows that being it obtained what? Straight line, therefore it validate the Freundlich adsorption isotherm and at intermediate pressure. This will be the equation. Okay, with the help of this equation we can solve some numerical question in the next video.